Alpha corrections, question E. This problem revolves around the multiplier. This is really the basis of the so-called Keynesian revolution of the 1930s. Okay, let me go to the next slide. Once again, this economy of ours. Notice we've gone back to red. We've gone back to government spending 100 and the personal income tax rate of 2. Okay, so the multiplier. Here's the question. If the government increases spending by $1, what will be the change in GDP? If the government decreases spending by $1, what will be the change in GDP? We do know that if government spending goes up by $1, that GDP will go up. We also know that if government spending goes down by $1, that GDP will go down. But if we did not know any better, we would make the assumption, which is false, that if government spending goes up by $1, that GDP will also go up by $1. That's false, as John Maynard Keynes showed. It is also false to say that if government spending goes down by $1, that GDP will go down by $1. False. All right. Okay. Where do I want to go with this? All right, let's try it this way. And here I'm explaining the concept of, well, in this case, the government spending multiplier. All right. So here's the idea. The government increases spending by $1. All right. Let me talk about a ludicrous example, a ridiculous example. Let's say the government has contracted the building of a hospital. All right. So the hospital has been built by the private sector, let's say, but it's owned by the government now. So the government gives the builders of the hospital $1, and in return the government gets the keys to the hospital. Now, what happens to this $1, which is now in the hands of the contractors, the companies that built the hospital? Well, this $1 will obviously immediately increase GDP by $1. But the question is, what will happen to this $1? Well, this contractor will have to pay the workers. Will have to, let's say it's a corporation. So this contractor will have to pay off the owners of this company and also the suppliers. So ultimately, this $1 will be distributed to workers, to the owners of the company, to the suppliers, and then in turn, these workers, they will engage in consumption based on their MPC, and part of this money will also be taxed away, right? So this is going to be the runoff, because not all of the money is going to be consumed. Part of it is going to be saved based on the marginal, excuse me, the MPC, the marginal propensity to save out of disposable income. A portion will be taxed away, right? T, personal income tax rate. And there are other runoffs, but for the time being, I just want to concentrate on these two runoffs, NPS and also T. Now, what about the owners of the company? Well, they too will consume a certain part of what they just got from the government, and they will save a certain portion of it, and they too will be taxed away. And the same thing with the suppliers, right? When the suppliers are paid by the contractor, they in turn gonna have to pay their workers, and the workers will. The workers are also consumers, so consumers will engage in consumption. So part of it is going to be consumed, part of it is going to be saved, again, based on their marginal propensity to consume, marginal propensity to save, and part of it also will be taxed, right? Okay, so in turn, because this is the multiplying process that I am describing or trying to describe, and then in turn, these workers, they will turn around and they will be purchasing goods and services from other parts of the economy, and they in turn will do likewise. And all along these different levels of consumption, savings, taxing, etc., this $1 will be multiplied over and over and over again. So actually, if the government spends an extra dollar, this $1 will eventually put a greater demand into the economy, thus multiplying GDP. So GDP will not go up by $1. It will go up by more than $1. All right. Let me do the calculations on the next slide for problem E. All right. So what are we trying to do? We're trying to calculate the government spending, in this case, autonomous government spending multiplier. All right. So what's the equation? Okay. Well, first a concept, right? First a concept. I've alluded in the previous slide to this mythical $1 extra of government spending. All right. So the idea is, if the government spends the extra dollar, all right, what will the multiplier be given certain runoffs? Because a certain percentage of this $1 is going to be saved, depending on the NPS. As this $1 goes from one level of the economy to the next, to the next, to the next, and to the next, part of this will also be taxed away. The personal income tax rate will also be a key factor here. All right. So how do we calculate the government spending multiplier? Well, 1, which implies this $1 extra of government spending, divided by the runoffs. In other words, NPS and T. And the denominator of this equation of the G multiplier is actually the denominator of the model equation. 1 minus MPC plus MPC times T. Again, what's 1 minus MPC? It's MPS. And this second term is MPC times T, the personal income tax rate. So what do we have here? 1 divided by 0.36. So what is the government spending multiplier? It's 2.78. All right, what's the implication of this 2.78? What does it mean? It means the following. If government spending, in this case, autonomous government spending, if government spending goes up by $1, then what happens to GDP? GDP will go up by how much? $2.78. And if government spending goes down by $1, then gross domestic product will go down by $2.78. What if what if government spending goes up by $100 million? Well, then GDP will go up by $278 million or billion dollars. And this works also in the opposite direction. If government spending goes down by $100 billion, then GDP will go down by $278 million or billion dollars. Okay? All right. Another way to explain the government spending multiplier is a little bit more mathematical. All right. So let me put together for you the model equation again. It's C plus I plus G plus NX divided by 1 minus MPC plus MPC times T. All right. Now, again, the government spending multiplier is equal to 1 divided by 1 minus MPC plus MPC times T. So where did I get the 1 from, other than just saying, well, it's this hypothetical extra dollar in government spending? Well, actually, mathematically, you see, 1 is the implied coefficient of G, isn't it? 1 is not the value of G. We know that the value of G is 100, but the implied coefficient of G is 1. Yeah, and well, and the denominator here. Well, again, this is the runoff. As again, this $1 extra progresses throughout the economy. Part of it, as it moves from one level of expenditures to another, it will always be a part of it will be saved, and part of it will be taxed away. Well, anyway, this is another way to explain the multiplier.